Going from right now about an average of 18 kW per rack, it's going to hit 50, 55 very quickly. That's with moderate AI, moderate accelerators, and on up from there. I've been doing this stuff as an industry analyst for, God, more than 25 years. I was here last year as Chief Research Officer for Intersect 360. I'm starting this new thing based on what I've been seeing happen in the industry. So, after that tangent, we're going to see a lot higher TDPs. This is the end of air cooling as a primary cooling for data centers. It's over. You can't handle that kind of density with air anymore. So liquid cooling's coming in. It's going to really do some bad things to budgets. All these systems, these components, are more expensive. OpEx, more, higher, more than folks are going to expect or believe. OpEx will be going up as well. And it's going to go up a lot higher if decisions are made to take the easy way out. We're going to discuss that. What's the latency on this clicker? Okay, there we go. Anybody disagree with that stuff so far? Right? Is that about right? Make sense? A couple of heads nod? Okay, great. And I've got the receipts to back all this up. I've been looking at it hard. The thing is, you know it's happening, I know it's happening. The people that a lot of the folks in this room are going to have to convince to make these changes, the ones that provide the money, they don't know. They don't have what I found, the background or the experience, the context to really understand it. They're not IT folks. They're management folks, they're business side folks, they're finance folks, they're not IT. The easy way out, you can't just outsource your way out of this. There's a number of reasons. The first one is it will be ruinously expensive. And I think you know what I'm saying when I'm saying outsource. That's give the workload to someone else to run for you. You'll lose some control, you'll lose flexibility, and there's going to be some security issues. You can't consult it away. There are a lot of folks out there saying, hey, AI, we know AI. We can help you with this. We can help you, with those problems in a lot of ways. The thing is, AI is not going to be this separate thing. It's going to be folded into all of the other workloads that you already have and the new ones coming up. It's not going to be a separate category for all that much longer. It's just going to be baked into the cake, which means that the computational complexity, the greater computational complexity, will be baked into those same cakes. And a lot of the things that I'm reading from the consulting types, the big name consultants and the ones that are trying to make a name, they don't know any more than we do, less in some cases, and the motivation is pretty much getting that next contract. We know this, right? These are not new things. The same thing happened with big data, same thing happened with the web, and many other trends. I do like that line, as I wrote this morning, that they're often wrong, but they're always certain. And they always say it very convincingly. The last thing, this stuff can't be ignored. Data centers, your data centers, are going to have to deal with it, one way or another. And there's going to be, and you know what? I did this from another thing. The last two bullets are pretty much irrelevant from a different presentation. I was in a big hurry, and I've had a head cold ever since I got on the plane over here. So, I'm going to take a step back. AI is the precipitator of these new higher computational demands. It's not going to be a short-term fad. It's going to be baked into everything. It's going to require what will be, to a lot of folks, new and expensive, power-hungry technology. There's no easy way out of this, and you're going to have to deal with the changes. And what I've found, based on what I've been seeing and the experience, is that What this is, the folks that have a handle on this are the big supercomputing centers. And that the discipline, the technologies, the practices that they use to make and run the biggest data centers in the world are what's going to have to be adopted by a lot of data centers that are going to be blindsided by this. Does this make sense? Ring any bells? Okay. I got one yes. That's enough. I'll keep going. There's a lot of challenges, a lot of solutions, though, too. The same stuff that the supercomputing centers are using, it's available to everybody. It's not secret. It's all about efficiency, wringing every cycle out of every piece of equipment you've bought and you're paying for and you're powering and you're cooling. It's assessing where you are maniacally. The thing is, when I first really started in the business, my first big thing was doing server consolidation for Sun Microsystems on the, if anybody remembers this, the E10000, which was a Cray system. And I was the last guy hired by that little piece of Cray in Beaverton, Oregon. We said, we got this 64-way system, right? 64 gig of memory, which was enormous back then. How do we fill this up? So we had a little retreat. I said, well, what if we put a bunch of applications on it and run it using processors? Yeah, we'll do that. Server consolidation, hell yes. So I started investigating that. And the first thing is, new guy, let's find out where data centers are in terms of utilization and stuff. Oh my God. If I would send them out to do this, and if they came back with a Unix system that had a greater average CPU utilization than 5%, that was a great big deal. That was high. That waste is still there. Not to that extent. But in everybody I've been talking to about this stuff, I say, well, what if I say there's like 30% waste in data centers? They say, well, they laugh. They say, you're way too low. In our data center, if we went through and put our hands on systems, and if we checked that they were actually being used and utilized, it'd be like 40, 45%. That's the stuff that has to be rooted out to find the room, both physically, in electricity, in budget, to be able to do this other stuff that you're going to have to do. So, where do you find these things? Where should data centers that don't know this stuff? A lot of you do, I know that. Where do you find it? There's a problem there that I'm going to try and fix or try to do my best. That the small specialized vendors are going after just the supercomputing centers. That's the low-hanging fruit for them. That's the folks that are most likely to buy and already understand what they're talking about. The large vendors are very segmented in their sales force. If you talk to, let me pick someone out, HPE or Lenovo or Dell, they're enterprise folks, and say, I've got this really big problem with this very complex compute load, they'll go to the price book. Some of the stuff that like the supercomputing centers are using isn't in their price book. They don't know about it. It's a specialized sales force, and it's tougher for a regular customer to know what the questions are to ask. The consultants, they kind of push what they're paid to push, which isn't really unusual, and you don't hear I don't know or I'm not sure come out of their mouths very often. They also flit from one thing to another. I don't have to do that anymore, which is kind of nice when I came up with my own thing. So I'm going to try and fill this gap. It's a new company, new animal. Still going to be doing analysis, right? What are customers using with technology, vendor briefings, stuff like that. But I don't have an agenda. I'm not going to be picking winners and losers. I'm going to provide clear and easy explanations of things like, for instance, I'm starting with liquid cooling. There's different kinds of liquid cooling. There's DLC, there's immersion, there's some new things on the horizon. Two-phase, single-phase, how many loops are you going to have? Probably 2 loops. What about dry cooling towers versus wet cooling towers? All this stuff. And the data's out there. It's not in one place. You got to go through the vendor stuff, their studies, you got to go through the ASHRAE stuff, you got to do all that. I'm going to try and pull it all together and make it understandable. The reason why is to give the folks, the data center folks, the ammunition to be able to convince their higher-ups, this is why we need to spend this money. This is what we need to do to maximize our efficiency. That's also highlighting the companies I know that are real that do it. And God, I was just at SC, and there were at least eight new companies doing liquid cooling. I don't know if they're real yet or not, because there's some that sort of are gamer, enthusiast liquid cooling companies that are sort of saying, well, why don't we just do data center? We already make some of this stuff. It's not the same thing. So I'm investigating that. I'm going to identify pretty long lists of companies that do things like that and that can be helpful. I'm not going to pick winners and losers. I'm not going to say, hey, go with them for all this stuff and hate them because they're awful. No. As soon as I realize that they're real, they have an understanding of what the problems are and they can handle them and they have before, I'll put them on my list. And they'll be on the website for free. I'm also going to be talking to thought leaders out there, both on the user side, on the designer side. I'm trying to set up, for instance, an interview with Bronis from Lawrence Livermore, who just did El Capitan. Love me some Bronis, because he does not mince words, and he will answer questions clearly, and I think provide some pretty interesting advice. So that's the website. I've got all the receipts on this stuff. If you want to talk, one other thing that a good friend of mine who was here brought up, he said, well, you know, because I kind of ran this by him just to sanity check it, said, could you talk to my bosses about this? Because they don't really believe me. Because I brought them all this. I told them all this is happening. We're going to have to invest and spend. And I said, can you come in as a third party and like yell at them and back it up? Yeah, I can do that. So yeah, that would be easy and fun. Anyway, so driving on, Industry Inquisition. Can the co-inquisitors please come up now? We've done this before. Vendors have 3 slides. Not 4, not 5, not 39 like someone sent, but 3. They have 5 minutes to make their pitch. Then we have 3 questions. And let's introduce them. Lily, say hello to everybody. Is that on? Probably not. Oh, it is. Is that on? Can you pot us up on this? There we go.
Hello, everyone.
And what do you do?
I am a second-year student in computer science. I'm studying at the University of the Witwatersrand. It's in Joburg, for anyone who doesn't know. Oh, and I'm mentoring a team at the student cluster competition.
And was a former participant last year.
I was a former participant and part of Team CHPC this year at ISC.
Okay. Reinhardt, same thing.
Yeah, my name's Reinhard. Also part of the ISC team from this year. I finished my degree in biomedical engineering, and I'm going to finish.
You took the easy way out, biomechanical engineering. Wow. Yeah. Try harder next time. Well, I'm kidding. So, anything else?
No,
okay.
That's it from my side.
So, we're going to get right through this. Intel, Ahmed, you are the first. Are you ready? Yeah, a little applause.
Thank you.
Oh, he doesn't need that. What? That podium mic.
Okay.
There we go.
Hello. Good afternoon, everyone. Yeah, I'm happy to be here again. So I have 5 minutes, so I have to really rush.
Oh,
which one is?
Well, it's labeled.
Okay. So at Intel, basically, in the data center space, we think that we have to classify the workloads according to their own use criteria. So if you go on the left, we have Xeon 6, which was just introduced. This one is with efficient cores. This one is Xeon 6 with performance cores. The key difference is this one is a stripped down version of this, such that we can fit much more cores on the same CPU. So this one can come up to 288 cores with 12 memory channels. While this one, the maximum is 128 cores with 12 memory channels. The key difference is that this one will have AVX512 for vectorization. It will have hyper-threading for multi-threading, basically. And what is most important for AI workloads, it is the only x86 CPU that has AI accelerators built in. It's called AMX, Advanced Matrix Extensions. With that, advanced matrix extensions, we could speed up AI workloads by a big bump, as you will see in the next slides. Also, we understand the importance of a balanced system. We cannot stuff many cores without getting the memory and the I/O subsystem and the networking to follow. So what we did, we introduced in Xeon 6 something called MR, so we support the MRDIMMs, which we worked with our memory provider. And the MRDIMMs, the key difference between MRDIMMs and DDR5, basically they go into the same slot. But the MRDIMM is multiplexed ranks. So instead of getting 6400 mega transactions per second, the MRDIMMs will give you 8800 mega transactions per second. And in a second, you will see the effect of MRDIMMs. And last in our portfolio for that center is the Gaudi. So the Gaudi is an AI accelerator. The Gaudi is an AI accelerator that is specialized only for deep learning, inference, and training. It gives around 1.9x performance per dollar compared to NVIDIA accelerators. So it is really something that you need to look at. So the AI world is not only one accelerator or other. Gaudi is really a good alternative that many customers are using today as well. So if I jump to the next slide, this is the effect of MRDIMM. So comparing DDR5 DIMM to MRDIMM, you can see in memory bandwidth workloads, you get up to 30% bump into the performance. What is exciting is some AI workloads make use of this as well, like the summarization of Llama here, for example. So it's really interesting technology that we are coming up, and we are the only CPU today that supports MRDIMM. And finally, okay, I want to conclude with this slide. Power efficiency, as Dan mentioned, okay, is extremely important for us. We want to help the planet save some power. So, for example, in this release, we are nearly 2x power efficient than Xeon 5. Okay, we are 2.5x performance increase compared to Gen 5 in HPC workloads. And lastly, because of AMX, which we have and others don't have, we are 5.5x up to 5.5x the performance compared to AMD and AI inference. Thank you. Am I on
Good
time?
job. Yeah, you are. You finished 52 seconds early, which is more. No, you're not going anywhere. Come back. Yeah, we're still. Yeah. No, we got the questions.
Oh, yeah. Go ahead.
Reinhard, you want to kick us off?
Right. Cool. So Gaudi is a competitive accelerator for LLMs, but can you produce enough to meet demand and gain significant market share?
So in terms of yield and the production, yes, we can. Actually, we just shipped a huge amount of Gaudis to IBM for their cloud. I cannot disclose the number, but it's a lot.
You could tell us. There's barely anybody in here.
Oh, yeah. I can tell you offline.
Okay. Okay.
But it's a lot, yes. We do have enough production in Gaudi. And by the way, we use TSMC to manufacture Gaudi. So.
Okay. Lily.
On on the second slide, we saw the speed ups with the MRDIMM. Does your fancy new RAM require any changes for the applications or operating systems in order to achieve those performance speed ups?
No, you don't need any change. So it is not operating system dependent. So it goes through the memory bus, and the memory bus really supports both speeds. Okay, so the operating system doesn't need to worry about it. Unlike, it is not hierarchical memory, so it is not one more tier in the memory. Okay, it is the same tier. So if you go to the hierarchical memory, you know, there is the disk, and then some slow memory, SSD probably, then DRAM, then cache, then last level cache, and then it goes to the operating the registers and the buffers. Okay, so and this one is the DDR layer. You can just replace it by MRDIMMs, and you don't need to do anything else. It goes into the same slot, the same memory bus.
Same slot, same socket.
The same socket.
Okay.
Beautiful for
Right.
users.
Nice. Okay, last question. Good claims from a guy who doesn't know the difference between 3 and 6. You sent us 6 slides, not 3. So I've got to get a shot in at that. I'm concerned, though, about Xeon 6. We're going to be on time with this?
It is already shipping.
Really ship in volume?
It is already shipping in volume, yes. For Xeon 6 AP, it is already shipping. The Xeon 6 SP is a Q1, but the AP
That's the
version,
one. Okay.
The SP is a Q1.
Okay.
Yeah, but the AP is already shipping.
Because Q1's like next month.
Yes.
Okay. Okay. Well, thank you very much. Let's
Thank
give him a big
you.
round of applause. Next up, HPE. And you know, I was just been in a horrible mood all morning, so these questions are going to be a little, maybe a trifle bit nastier than usual, but they kind of help calm me down, so here you go. And hold on. Reset. Start. 5 minutes.
Matai Philip, I run the HPC business in UK, Ireland, Middle East, and Africa. So with the 5 minutes, let me share with you our vision. As a company, we talked about purpose. Our purpose is to advance the way we live and work. And how do we do that? One of the way we do that is with our leadership in supercomputing. And 2 weeks back in Atlanta, we announced the first 3 fastest supercomputers were HPE. The top 7 out of the 10 fastest were HPE. And what I am more proud of is our leadership in green supercomputing. 16 of the 25 is, the top 25 green is built by HPE. The question, I think, is why does it matter? What is the impact it creates? First and foremost, I'm proud of it. It promotes award-winning research. Dr. David Baker, who was one of the Nobel Prize winner this year for chemistry, worked on one of our supercomputers. We are leveraging AI to build new drugs that can get over the antibiotic resistance that is affecting a lot of the deaths at the moment. If you have ailing, sick people, you understand what infections and antibiotic resistance can cause on the well-being. And we also make the car go faster, whether it's the Formula One or the Formula E. So these are the impact this is creating. And it's not just we create this for supercomputing and research. What we are doing, we're doing what we have done in the past with our history. If you remember what digital equipments did with Unix and the mid-range systems, or what the Compaq did to the x86 Wintel business. We are taking the goodness we are learning and building in the supercomputing world into mainstream computing. So as part of that democratization, we are offering choice. We are offering choice to our customers, whether it's Gaudi 3, whether it's the AMD GPUs, and not to mention the NVIDIA. And we are also offering choice in terms of different form factors, understanding, giving the customers that ability to scale. In addition, we are building a software ecosystem. I've put the logos down, whether it's MapR for Data Fabric, Determined AI, and Pachyderm are available in open source. So if you are interested in doing experiment tracking for your model training, if you are interested in doing optimization, you should check out Determined AI, or whether it's Pachyderm for data governance. So we are, and it's not just HPE, we're working with our partners. I think we've got VAST here, helping with, in terms of building the whole end-to-end solution for our customers. Then the question becomes, what are we trying to solve in the AI space? Our vision in the AI is how can we enable organizations to deploy AI at scale to get that benefit? And I think Dan mentioned very well, eloquently, much better than me. We're trying to solve 3 Ds in the AI space, which is data, data center, and data skills. And you can see how we are trying to solve that in different aspects, whether trying to get the right data model, whether we can deliver data versioning for governance, and also trying to build the skills. To help build the skills, we've come out with 2 new solutions. One we call this as Private Cloud for AI, which is a turnkey solution to help
30 seconds left.
small companies leverage AI inferencing at scale. And with the last, and I think for the research community, we have the HP Labs, and we have collaboration agreed with Dr. Happy Sitole on how we can work together to move forward the agenda for HPC in South Africa. So with that, I end my, thank you.
Right there. Nice. To the fraction of a second, can I have the clicker, please? Okay. Reinhardt.
Okay. You highlight a very large number of HPE products and services in the slides, but what do you think is the most important for real-world customers?
So I think what is most important is solving a business problem, right? So it's about how do we build this together with software, hardware, and services. So we go and if it's a CFD customer, how do we solve his CFD problem?
You
And that's
took
what we're
that
doing.
from our conversation we just had when we were putting these questions together. Good job. It works.
Listening is the main part.
Are you ready, Lily?
So when I was looking through the presentation, I saw everything you've done, what are you doing, but what will you be innovating in the future? What are we looking for to come? Like, what's the plan?
I think we got like a keynote coming in, and after this, where we've got Dr. Utz from our HP Research Labs, who's going to give where we are taking from an innovation perspective. But in terms of, it's very simple. We look at are we making the world better for us and our customers and the environment, right? So that those kids who came from the Cohen High School has a world to live in. That's what we are looking at.
I like that vision. I'm excited to attend the keynote then.
There we go.
Okay. This is something that kind of bugs me. First of all, that I misspelled catalog. I don't like that, but I'm tired and I've got a cold. The thing is, when I'm talking to customers, one complaint they have about vendors, not just you guys, but others too, is that they say, I've got this problem. And the vendor says, oh, we can help you out. Just, we've got everything. We can help you solve that. He goes, okay, but what should I pick? Well, anything you want, because we have it. And can you truly help prescribe specific answers, solution answers to problems that customers have, because they're out of their depth in a lot of things?
No, I think it's a truly an issue within the IT industry as well. But, HPE believes in innovation and choice. But with that choice, the choice paralysis comes in, right? But what we are doing to build is we're building industry vertical use cases and solution catalogs very specifically for AI business and also around the HPC. So I think you mentioned, about having a specialized team for HPC. HP has, I think, the largest dedicated HPC and AI team in the industry, with not just sales and pre-sales, but also a large solution application benchmarking team to help customer choose that.
To benchmark customer problems.
Correct.
Okay.
Correct. And typically, we would just use it for, okay, help me achieve, X number of petaflops. But we are moving more into solving an issue and having continuous solutions.
That's good. That's good. Great. Well, thank you very much. Good job. Jacques from Dell. Bringing fluids up with you, very good idea. It's good to remain hydrated during these sessions. Good job.
Same as you. I'm also nursing a
I know.
bad flu at a point.
Yeah.
Yeah.
Which, by the way, you two have caught now, too. Just added
No,
benefit.
I dodged it, but 1, 2, 3 now.
You're ready to go.
Great. Thank you, Dan. Can you guys hear me? Okay, great. My name is Jacques, and I'm not an alcoholic, but I do work for Dell and Pinnacle. So you need to have some sort of a way to cope with things, right? So I'm talking to you today. So I want to talk about Dell's AI Factory. So I actually checked the link that you guys sent for last year's video. I saw Ryan had a tough time, so I'm expecting the same. Thank you, Dan.
We'll see what we can do.
So something new of Dell is this thing called the Dell AI Factory with NVIDIA. Now, we've heard a lot of stuff being talked about today. I want to talk about the conversation. So if you want to talk to someone about AI, it's about understanding that use case. The use case is extremely important, and it even comes back to how you tell and explain and help a customer or a HPC customer around what hardware, software they actually use. And I'll show that a bit later about how that use case scenario affects how you take AI to market. AI is heavily centric around data. But the customer's challenge is his data is everywhere. Yes, in an HPC environment, data is consolidated, but it's also spread around. You get cloud data, you get data center data, and you also get edge data. We're seeing that hybrid AI is also picking up quite a lot. Everybody that's got a phone has an AI agent. Agentic AI is also happening. And that's where the future, from what we can see, is it will be heavily focused around having agents with smaller language models than larger language models. More than 30% of having an AI conversation is around services. It's about strategy, it's about data, it's about platform. And that strategy is what customers need. And I think you mentioned it earlier as well. Customers don't know where to start. And the people you have to have that discussion with is the business people. That's how AI wins. 10 out of 12 AI projects fails because there is no ROI. There is no business impact related to a large deployment of an HPC environment or just an enterprise deployment. Software is the next part. So what NVIDIA did is they actually went and they used industry standard open platforms and they added support to it. They created different modules, NIM modules, Omniverse, AI Enterprise as a framework that's got enterprise type support. So if you are deploying AI in a business environment, uptime is key. Support is crucial. You can't wait to get your application from one version to another version. It must seamlessly work with the right support. And at the end of the day, infrastructure is just as important. And at Dell, we believe right-sizing that AI investment. And that is why identifying the correct use case is extremely important. The business value changes per customer, so there is no blueprint, one size fits all. It's about understanding that business value, the reason why they want AI. Is it to perform better? Is it to outsmart? Is it to be faster? Is it to be more cost effective? Also, when it comes to the feasibility of that AI investment, there's a lot of factors that need to be involved. There's the people, the processes. I've seen so many customers that's looking at implementing AI with 0 processes or the capability to embed AI into that processes. And that's irrespective of what type of use case you choose. But what we've seen is most of the companies out there, they're prioritizing Gen AI. Gen AI is the low-hanging fruit where they can achieve business return on investment. And when it comes to right-sizing that AI investment, the use case is more important than anything else, especially when it comes to the data patterns. Identifying the correct pattern for how you want to implement that machine learning model or just a basic inferencing or a fine-tuning model in an AI environment heavily depends on the type of hardware then that you can implement. And the last thing you want is to buy something that you can't get value out of it. By using this methodology that Dell provides, we can assist customers, partners, resellers, ISVs, and I'm actually getting a lot of that request where we've got a lot of software vendors that's asking for guidance. How do I make that model that we've spent 8 years to fine-tune?
8 seconds left.
8 seconds. How do I make it palatable and affordable and make it more mobile to have my AI closer to my data? And with that, my 5 minutes is done.
Okay, you're 2 seconds over, but
Is that a penalty?
we'll let that go. Reinhard, go ahead, let's fly.
So, you say that Dell has the industry's first end-to-end enterprise AI solution. What does that really mean?
So it's a 360 approach. So it's purely not selling hardware or software. It's having a conversation, a consultative approach with the customer. If you can't walk in that customer's footsteps and understand his business, you can't provide him a solution. That is a services-led consultative approach to understand that requirement, and that is where the one-size-fits-all, the consultative, the partnership with NVIDIA, and top-class hardware to provide AI in a box.
And you're saying that Dell was the first to implement this?
So Dell pioneered a lot of the blueprints and the ways that they take AI to enterprises successfully. As universities and as a lot of open source communities, they started with AI. Most of it was research-based, but there was not a lot of business intent around that AI. It was to show that, hey, this is possible, this is where technology is going. Dell was one of the first OEMs that could say, this is the business value of that AI, and this is how we propose you do it.
Thank you. I'll pass it to Lily.
Okay. Lily?
Other vendors have talked about their AI factories. How is yours
One
different?
just before.
Yeah.
Use that term, yeah. Because we saw all the slides beforehand.
No, that's
Go
fine,
ahead.
that's fine. So what makes us different? So Dell has been around for quite a long time, as well as NVIDIA, and the relationship between NVIDIA and AI was there from the start. So we actually started with gaming PCs. And that's where we started with Alienware, and we built some of the best gaming-capable machines out there with the help of NVIDIA. So we've got a lot of history and IP around creating an experience for a customer. And I think that's what sets our AI factories apart. It's not just a GPU or a software or a consultant that you have, is the years of experience that comes with AI, with Dell's AI factory design, the way that it's implemented, the way that it's being proposed and talked to customers. I think that's what makes us different. A GPU is a GPU, a server is a server, a memory is a server. It's how do you amortize and make that palatable for a customer. That makes us different.
Okay. So the legacy kind of.
Sorry?
The legacy, like the history behind the
It's
company.
easy. So I worked at Dell when I still had hair. So it's quite a long time, and Dell is in my blood. It's part of my family, and knowing and growing up with that company, you can actually understand and value the purpose they're bringing to the industry. And that's why there's a lot of legacy that Dell brings to building solutions for customers.
Okay. There's a lot of NVIDIA content in your slides and what you've talked about. They are the leader of accelerators, absolutely, AI software, but what's your added value? You know what I mean? You're talking a lot of NVIDIA with NIMS and all that.
Yeah. I think it's about the testing and validation and the partnership between Dell and NVIDIA. I think that's the value. So yes, everybody can go and download NVIDIA AI Enterprise, load it on a piece of software, but when the going gets tough, what do you do? So Dell is renowned from a support and a consulting perspective to be world-class, and the way, again, how they interact with their customers is what is setting us apart as Dell Technologies. So the story with Dell, NVIDIA, everything goes together better with Dell makes sense for that specific reason. Is the fact that the history is there, the legacy is there, and just the way that we consult and talk to our customers sets us apart than our next competitor. What makes a Dell solution with NVIDIA different to the guy next door.
Okay. You know, there are going to be other accelerators out there too. Just
So-
saying. That's a fourth question.
Yeah.
That's against the
I'll
rules.
take it.
We'll talk.
I'll take
We'll
it.
talk. Okay.
So open source is thing that we love with Hugging Face. There is definitely a market for open source. What we've seen is to make AI palatable, the support needs to be there.
Okay, great. Well, thank you very much. Appreciate it.
Thank you.
Huawei. Welcome up, Colin. Give you the clicker. Also bringing his own liquids. Good job. Thank you. And hold on. Reset. Go.
Good afternoon, everyone. My name is Colin Maposa. Basically, I'll take you through where we are sitting in this whole digital transformation. Huawei is one of the companies that has came through to penetrate the industry with most of the solutions that are there, where to say we value the data of the customers. And with it, it takes us back to say data is the new oil. And with it, customers, they value their data. And it has to be saved and accessed at any time and from anywhere. And with it, you have to have the right tools. You have to have the right equipment for you to achieve that. That is coming from your software to the hardware. Now, coming to it, we will have to take a look at where do we save that data to. So initially, we are highlighting some of like the smart government, the smart healthcare. And those are people who have been overlooked before when it came to data. Banks were the ones which were more like on the tech service, like to say they were prioritized with it. But now we understanding that data is to say with those customers, we have to save them their data and they can make most out of it. So now with the right tools, we're talking about the data collection, coming to the data processing, drilling down to the model training and the interface. So now we have to have the right management tool. That is the Huawei Data Management DME. And with it, it gives you all the data catalog, coming to the data analysis, understanding your data, drilling down to the data policy, where you can set policies on which data, value your data, where it can sit, where it can reside, and where it can save you the most. Yes, with it now, with the hardware, also you have to have a hardware which is ready for saving that data. Now with the AI, we're talking about the Ocean Pacific. With them, all these systems, they are AI ready with the integrated hardware to save that data. And also, yes, we play well with other parties. That is talking about the third parties that are there in the ecosystem. So you can deploy in a you can deploy the solution into different hardware. So now with it also coming to say with the third party vendors, with them, you can integrate that software when it comes to deploy the solutions. So the highlight of it is to say, Huawei doesn't sell products, Huawei sells solutions, in which that's one of the questions which was highlighted before to say, what do we do to address the customer's problems, in which this is where we come into play to say we provide solutions instead of the products. So now coming to it, we have the new products, the A310. With it, it's an entry-level hardware, basically AI solution, dedicated AI storage, which is there. So with it, it has a full stack end-to-end. Now also to highlight when it comes to virtualization, we're talking about data center solution, which is DCS, more or less like the other leading virtualization software that are out there. And with them, they come with the AI-ready capabilities, which gives you that end-to-end. And drilling down to the speed, obviously, we're talking about performance. Performance, that's where we're talking about the bandwidth, and we give you about 400 gig per second, which gives you the optimum performance on your network, and giving you that end-to-end fast training or interface with the acceleration. And also the last part is to say, to highlight the support for multiple ecosystem. We understand the customers, they invest in different solutions in their data centers, and with it, they have to integrate to achieve one point, and which is accessing their data. So this is where also we say to support also the multiple ecosystems that is end-to-end from the software and also the hardware. And the last part is to view what we have, and with it having the AI-enabled hardware, we're talking about the next generation, the near storage computing, where it's equipped with processing itself to give you that optimum performance and that intelligence when it comes to manipulating or managing your data. And having to say with the performance achieving up to 24 million IOPS, and also with the high speed of like about 500 gigs per second. And lastly, we are now talking about the teraflops, which are there, which is about 36,000. And I think that should be me in a nutshell.
Is that it? Good job. 30 seconds early. We're getting back on time. Can I get the clicker? Thank you so much. Reinhardt. Excuse me.
Representation. Who do you see as your greatest competitor?
Okay, coming to say the greatest competitor, I believe in this industry, we don't have competitors, we have partners whom we have to work together to achieve the solutions that are out there. So with it, I would say the question should be saying, who are the good colleagues that we work hand in hand with? So
You've got some competitors. Come on. You're not partners with DDN, are you? You guys real close, working on deals together?
yes.
Yeah? Okay. Lily.
I noticed, second slide, you said unlimited scalability, and then you put some numbers under there.
Yes.
4,096 nodes. What's the deal with that? If it's unlimited, why is there a limit?
Okay, so when it comes to deployment, initially with the customers, they can start small. And then now, as they scale, we have to give them that ability to scale seamlessly. And then scaling seamlessly now is taking them to say they can have multiple clusters in an environment, and then coming to play an effect of the geographical sites, like to say now you can add more clusters up to all those nodes, up to 4,000 nodes. So with it, it drills down back to say it's the scalability of how many nodes you can add in your deployment as you grow. And we have to give that opportunity to the customers to scale seamlessly as they grow to meet their needs. And yeah,
But is 4,096, is that the high end? Is that as high as it goes?
for now.
For now, okay. Have you tested it at that? Has it been tested at that many nodes?
Yes. So with Huawei, we have about 12 R&D, which is the research and development that is global, in which this is where most of the time they break and make things to give you these accurate numbers.
Okay. So what proportion of your storage business is HPC oriented versus enterprise? Because AI is not going to be this separate thing forever.
Yes. So with it, when it comes to the business, haven't invested much to it because it's a new norm now with it. But now with Huawei, the approach of it is having the future-proofed hardware and solutions that are AI ready. So with it, as we grow, this is where like to say we'll invest even more into that business of it.
Yeah, but AI is not going to be separate. It's going to be sort of HPC oriented or enterprise oriented. It's not going to be, it's going to be folded in. Which way, do you do, I guess what I'm really asking, do you do much HPC oriented business?
Yes, we do.
Okay,
That's good.
good. Thank you. Appreciate it. H3C. Good to see you. No slides, right? I don't think, no slides. Impromptu talk, gutsy call. We'll see how it goes. And we'll be coming with our questions on the fly, too.
Let's put it this way. When I initially got the brief Dan said three things. He said, no builds, no fancy animations, and no BS.
Said 3 slides, though, didn't it?
Yes, you did say 3 slides, but I mean, that took the 3 slides out of the equation completely.
You said 39. Go ahead.
It was, in my defense, it was the wrong slide deck that I sent to you. But anyways, so for me, this opportunity and seeing that this was the first time that we as H3C is actually at a conference like this, I thought I'm going to go completely off the reservation and I'm going to answer a question or 2 questions that I get asked most by people. And that is, who the hell are you and why do we have to, look at your products? And it's very simple. For the people in the room, who knows the company called 3Com?
3Com, sure.
Okay, great. We 3Com, all right? We're the brand of 3Com, and it used to be Huawei, our friends from Huawei, but that turned into HP later on when we got acquired. And therefore, we have that brand, and it's been living for the last 15, 20 years, and we've been developing our product with one common operating system called Comware across everything. So we use it for our switches, we use it for our routers, firewalls, you name it. One single operating system. Which brings us to the why H3C. Well, if you, from a training perspective, are proficient in one of our products, you automatically become proficient in all of them. Okay, so we're a $2 billion company, Chinese company, and we have 20,000 employees. 10,000 of those employees are R&D staff. And because we are owned partially by the Tsinghua Uni Group, it means that everybody we recruit comes from the Tsinghua University. Now, anybody from WITS will understand there's a little bit of a relationship between the Tsinghua University and WITS, okay? So it's not unknown to people around the country. Okay, second thing, simplicity. Why do you have to do business with H3C? Why look at our product? Because we make things easy. We do not have a catalog of servers that is 50 pages long. We have a few servers that we've selected, and those are specifically workload servers, plus includes AI, includes GPU servers, includes a vast range of things that we can do with a little bit. We call them Lego blocks. So, in our case, we put something down, we put some software on top of it, you want to change that. No point in removing that hardware from the equation. We just build on top of it, and life goes on. We also have, in terms of our networking, we have released 800 gig networking that is based on PCI 6. So, sustained. We have 48 port switches already available for shipping at this point in time. That brings me to the next point, is part of the Tsinghua Uni Group, we have a chip manufacturer in-house. So during the time when we all were waiting for chips that were stuck on the ocean for however many months, it was a lot of our competitors that couldn't fulfill, we had absolutely no chip shortages, because part of that group is also the silicon manufacturer and an actual silicon mine. So from that perspective, we experience zero downtime, okay? Part of our manufacturing process is 85% of everything that we produce is touchless. No human being touches it at any point in time. It is all automated. It is all done in such a way that the human element, that DIMM module that you push into the motherboard that doesn't click on the one side, everybody's been there if you build a PC.
Yeah,
Those kind of things have disappeared. Now, what does that do? It gives us about a 35% decrease in out-of-box failures. Okay, which makes a huge difference, because if you think about it, out of a big project, if you've got just a 1% or a 2% failure rate out of box, it affects the project quite dramatically. Second thing, well, Another thing is
Gonna have
our
to-
licensing.
We're gone over on the 5 minutes.
Are we?
Yeah. Sorry. But you can tell them all later on at dinner.
Yeah,
So-
I think they can meet me at
Yeah,
at our
yeah,
booth.
yeah.
Sorry.
Reinhard, you got any questions? Okay. Bring it.
So you said you had a small catalog of solutions, let's say that. So it's such a small catalog, although I can see the benefits. Are you able to truly tailor your solutions for industry or those that for customers? Essentially?
Yes, 100%. So the stance that we took on that is instead of creating a SKU per solution, we use a configure to order system where we actually take the existing parts that we have, existing infrastructure, existing features, and we can consolidate that into one tailor-made solution for you.
Okay. Lily, you got anything? This is really putting them on the spot, by the way. We didn't see the slides, so they didn't. Go ahead. I just want to, yeah.
Like I say, listen twice and respond once.
Maybe I just want to get an idea of the size of your company. Could you maybe let us in on what's your latest, biggest project that you've done with the company?
Absolutely. Anybody know Alibaba Cloud?
No. Oh, yeah, no.
We are the preferred hardware supplier for Alibaba Cloud. So that is the kind of scale of product that we do and the kind of projects that we are involved in.
Thank you.
Now, do you, when you say that you've got a limited number of systems, are you making like your own motherboards and things? Or are you sourcing them from somebody else?
No, we source those motherboards. We work in conjunction with AMD and with Intel from a infrastructure perspective, from motherboards and so on. We also use the industry standard processors like AMD and Intel. We support Mellanox. We support everything that we have from an industry standard server perspective. But the fact is we can manufacture those chips under license by ourselves.
Okay, great. Well, thank you very much. We appreciate it. Next up, oh, that was the slides to be sent. Pinnacle. Roger. You ready? Clicker. Excellent. Let you get positioned there. And you're off.
Can I go?
You can go.
Good afternoon to you folks. My name is Roger. I represent a company called Supermicro. The name Pinnacle that you see is how we get our wonderful product into this wonderful country of ours. So let me just do this. So I want to talk a little bit about Supermicro. What we are is a manufacturer of infrastructure. We're a hardware manufacturer. So if I may, if we're talking around artificial intelligence, let me just make something clear. My wife will tell me that she's been dealing with artificial intelligence for 29 years because that's how long we've been married, and I'm definitely artificially intelligent. So when we start talking about AI, obviously I would just want to try and bring it into layman's terms because I'm a layman type of person. We manufacture the human body. The heart of the human body would be the accelerator or the CPU or the GPU that all of my colleagues are speaking about. And the brain, in my opinion, would be the software. So in other words, to get this AI body moving or this AI vehicle moving, we manufacture the body. We've got manufacturing plants in different parts of the world. And starting in where our head office is in America, we've been around a long time. We do wonderful things. One of the unique things about Supermicro is that we don't just manufacture hardware, but we manufacture hardware, we integrate that hardware, and we get it to a situation where it's a plug-and-play solution. So we'll take the GPUs, we'll take the software, we'll take our racks, we will liquid cool our racks. We do it ourselves, because obviously you can imagine the amount of power that the GPU is producing. It's producing a lot of heat that needs to be cooled. So cooling is a big challenge that we face in the AI world at the moment. And Supermicro manufacture the body, but we also cool this body down, and we do that in-house as well. So we will be able to deploy. How many minutes do I have left?
You've got 3 minutes left right now. You're going pretty quick.
So we'll be able to deploy a full integrated solution, plug and play. From the time that we get the design, we do the design, we do the consultation, we do the deployment, and we do the testing. So it's plug and play. The rack arrives, or the row of racks, which I'm about to show you, arrive ready to be tested and to be deployed. And because we're able to do that, this is what we were able to do very, very recently. It was in the press. Supermicro were very proud to be a part of the XAI Colossus cluster. It's got 100,000 NVIDIA GPUs in it. So where is Mervyn Christoffel still here? Because earlier he was speaking about someone said to you, you want to do 100K GPUs? Supermicro have done it. We've done it with 12,500 liquid-cooled 4U servers. You guys can read it in 1,563 racks. So the main thing, the point I would like to make is that we've done it. So now, that's wonderful. We are surrounded by very intelligent people, and every talk you have, you will hear wonderfully intelligent South African people. Our plan, our desire, our aim has to be to get this into the country. Whether it's through Supermicro, whether it's through our competitors, irrelevant. We need to have this type of rollout into this country because we have the expertise here. If you look at the different divisions that we have, SKA, Sorrel, there's so much brain power in our country. There's so much brain power in this room. I would love to speak on behalf of this country to say, we really, we've got the expertise, we've got the people that can do this. We need to have this on this continent, for this continent. We don't have to stand back for anybody any longer. I'm probably going to get fired for saying it, but I'll get fired for saying it. I'm a proud South African. We need, am I right, Dr. Satoli? We need it on this continent. Thank you so much, and we can do it. We have the expertise. Let's just collaborate, and let's make an impact to our country. Thank you.
Rousing ending. Let me give you that. Good job. And one thing on the questions, we might change them a little bit because we weren't sure if you were from Pinnacle or
No.
Supermicro,
I'm
but
from
you're from
Supermicro.
Supermicro.
Yes,
So
sir.
you can change your questions
My
because
bad.
he tried to, yeah. That's our fault. So,
What segments does Supermicro serve? So, well, I'm assuming this is
I mean,
a Pinnacle idea, but
No. I can understand that. So it's a very good question, Reinhard. I think Supermicro typically have played in the HPC space. We're very strong there. We're very strong in government rollouts. We're very strong in the big OEMs. We've done a lot of work for OEMs. And we haven't been very strong in the enterprise space, mainly because we're a manufacturing company and we're not a branding company. Our branding is really poor. So especially in our country, we haven't done well in the enterprise space because our competitors brand extremely well. Dell brands brilliantly, HPE brand brilliantly. So you can imagine an enterprise person in South Africa making a CIO making a decision. He's going to go with a good brand like Dell, a good brand like HPE, but they are branded so well. He doesn't know how well Supermicro, all the good things Supermicro does because we don't brand that well. We will be doing the enterprise space. We have had a lot of successes there. That will only continue. But traditionally, in the HPC space. Does that make sense?
yeah, and I'm assuming that's something you're actively working on.
100%. We have to. My boss keeps reminding me every day.
Lily?
I love the proudly South African thing. Agree with
Thank you.
Proudly South African. Does Supermicro install?
That was one, again, that was
Yeah.
because we weren't sure of who
My
it
bad.
was.
Do you guys install and implement liquid cooling with the systems you sell here locally?
We do, Lily, 100%, and we do that in-house. So we don't outsource it to anyone. It's one of the newest sort of innovations for the Supermicro offering is liquid cooling that we design and implement ourselves. And that's the cluster that we showed you just now. The rollout was done as quickly because we did the cooling ourselves.
Can I sneak a quick one in just on the back of your question? What's the proportion of customers asking for liquid cooling these days?
A good question. I think that'll depend entirely on how much GPU power is needed. So the more GPU power you need, the more cooling you need. The more cooling you need, the more power you need. So it's proportionate. A lot of our latest rollouts have all been liquid cooling. I don't think we've done much liquid cooling in any capacity on our continent yet, and that's going to change. We've done quite a few in Europe, So liquid cooling is coming. A lot of our data centers aren't really prepped yet and for liquid cooling. They're still all for perimeter cooling, but a lot of the bigger data center providers are starting to provide liquid cooling, so then the liquid cooling will follow after the infrastructure is in place for liquid cooling, the pipes and all that kind of stuff.
Okay. And last question. Well, actually, you just answered that. I mean, we saw that on the slide. Now, knowing that you're from Supermicro, so I'm going to substitute a question. When you're saying that you're making your own liquid cooling, is that completely made by Supermicro, or like including the cold plates and things?
Yeah. So we manufacture, we design, we patent, so we label, we design the cold plates, the piping, we do all of it. It's
And everything up to the rooftop.
100% right.
Wow,
And we do it,
okay.
we've done it ourselves at our own plant. We feel very strongly in doing that in-house now.
Great. And sneaking another one in, one of the things that I forgot to mention in my thing, there's a positive TCO on liquid cooling these days.
Proper.
There didn't used to be. That's even from starting from zero. Would you say this? Would you agree with that?
Yeah, 100%. And we've
Okay.
seen that now, that
Yeah.
the more efficiently we design, the better the TCO. So that has happened because we do it in-house, all R&D is in-house, so therefore the return on investment is a lot better. Yeah.
Great. Well, thank you very much. Good job. Oh, go ahead. Yeah. One
Can
more.
I just ask one more thing? To Werner or to Dr. Satoli, maybe at next year's conference, sorry, Dr. Satoli, can I just have your ear for 1 minute? Maybe at next year's conference, maybe you can add a segment. We've been doing this for 18 years now, am I correct? Maybe next year you can find some of the students, because I was absolutely blown away last year by what the students are doing, what our young South Africans are doing. Sorry, I'm on my soapbox again. But maybe next year what we can do is take a segment or a talk of 2 or 3 students from 10 years ago, where they are today, what they are doing today, and how they're making a difference to our country. Can we do that? Thank you. And
That's a
thanks,
great
everybody.
idea. Good job. Thank you. Vast. Kim? Oh, sorry, you were off over there. The clicker?
So, being a software company and standing up here to talk about hardware, no. So I've taken a different approach to my slides. I was at the conference in Kruger last year and I got to see the punishment some of the guys went through. So what I thought I'd do is just give a quick little brief on why VAST for HPC, AI and big data. A lot of the statistics you can read for yourself, but we've literally redesigned the architecture from a direct attached and shared everything. When you look at vendors that have stood up here before me, a lot of the guys have based their storage technologies on Google's parallel file system, which launched in like 2003. It's 20 years old, and you start looking at big data, you start looking at AI, and you kind of think to yourself, some of these architectures aren't going to be scalable. If you look at Lustre, where Lustre is today, and my reference that I'm going to close on, we'll talk to the performance that we can see of a parallel file system versus a Lustre file system, or let's just call it our NFS system versus the parallel file system. The other thing that we've already been looking at is really in the sense of scale. I talk about the fact that we can scale 10 times larger than parallel file systems. Every single system that you build on a parallel file system at some point is going to have a trade-off. We want to add more CPU, you're going to be adding storage and network together with that system. If I just need to scale with CPU, let's just scale with CPU. And if I need to scale with storage, let me just scale with storage. And the 3 things that we've put our little hats on is that we're going to focus on industry standard servers that everybody stood up here and spoke about. We're going to focus on NVMe as the connectivity option with InfiniBand and NVMe over Ethernet. And then the third one is going to be focused on NVMe SSD. And then how do we put that all together and scale with software? The next thing really is to talk about how do we access our data. So if I'm a research facility and I've got researchers in different parts of the world or different parts of the country, and I need to move my researchers around, how do I give them access to that data at a global level in the different locations that they're sitting? So if you come and have a chat to us, we'll talk a little bit about that. But think of it again in the sense of being able to take an NFS data store and present that via S3, using the same security models that you might have implemented for NFS and making sure that those security principles follow through. Right? We talk a little bit about sustainability. I think the biggest thing around sustainability is using less hardware. Now, the fact that we say use less hardware, but we talk about infinite scale. We talk about exabyte. This is huge. The thing is, if we can focus on data in the sense of what it is, and normally HPC data structures don't lend themselves well to compressibility and dedupe. But we've come up with our own invention called similarity, and similarity allows us to get 3 to 1, kind of data reduction. Data reduction is what is going to give us our efficiency and is what is going to make us more sustainable in the data center. Dry mouth syndrome. Anyway, so one of the big things that we did when we launched in 2019 was to say that we need to get away from tiering. If we want to unlock data for AI and for HPC type workloads, we need to try and bring as much data to AI as possible. So in that sense, we've also, when you talk about consolidation, not just for HPC, but we can also look at then AI. We can look at general NAS purpose workloads. For that matter, even your backup architectures. Just literally bring one data platform that can access everything. Multi-tenancy, quality of service per tenant, just really allows us to be able to not have to move data, between different silos, but be able to just, allow people to access data when they need it and how they want to access. So again, I think, in me closing off, I wanted to talk about tech. I was at tech in July this year, and standing inside inside Stampede 3, this is 5,000 odd servers, and we were the chosen platform behind tech for Stampede 3.
30 seconds.
Yeah. And what's really cool is that the 12 petabytes of data that we put in here was literally just 12 U of rack space. And if you talk to Tommy, who hosted me, they're now actually looking at just expanding Stampede 3 storage from a vast point of view for Vista, which is their GPU cluster. So we're not building islands of capacity for different HPC clusters and AI clusters. We're using one storage platform to go between two different ones. The other very cool thing is around the performance. These guys were able to push performance on our storage platform 15 times and 30% more to, let's call it time to value, or in the sense of response times. So I think, have a look, the QR code is there. You can scan the QR code, it'll take you through to a couple of Tommy's talks on YouTube and to our website as well.
Got to rein you in there. Thank you so much, and let's go to the questions. We're almost back on time, people. This is pretty good. Reinhard.
You've sort of answered this question, but are you solutions, hardware, software, in the cloud, or on premises? Can you just clear that up?
Yeah. So we're a software company. To be quite frank, we work with the likes of HP. I think you saw an HP slide. I actually probably need to give you a beer. But from an HP point of view, Keynote for files, so we'll work with our vendors. We work with Supermicro as well, where they will OEM our software and sell it as their solutions. And then Vasta on Cloud, which we launched literally last year, December, allows us to put the appliance into the hyperscalers. So Azure, GCP, and AWS. Yeah.
Okay. Lily.
Are your solutions for HPC, AI, and big data essentially the same, or are they different?
So, yeah. Well done. No, so I think, from a vast point of view, when we launched in 2019, the focus was AI and big data. The biggest area where Renan, our founder, looked at the market and said to our customers, where do we need to focus our technology and our design efforts? And a lot of it was focused on HPC in the beginning to make sure that we could be parallel and performant. But then as we started learning more about AI, it became more about the big data, and being able to scale. So we do see them differently. The performance workloads and trending is different. And that's hence why we've introduced multi-tenancy and quality of service per tenant, so that you can actually carve up the storage and not have to work with silos. So a single data platform, single global namespace with huge scalability.
Okay. You cover a lot of use cases and you get a lot of claims in there. Is there any customer situation where VAST isn't the best choice?
Yeah. Definitely. You know, we've, like I said, I don't want to say we're purpose-built, but, you know, there are protocols that will not work with us today. So, for instance, a block protocol like Fiber Channel, iSCSI, that kind of stuff. We are launching NVMe over TCP at the end of the year, which is going to give block access. But again, you know, if you're looking at low latency for SQL databases, those kind of things, that's going to still be something that should go to a storage vendor like HPE, where they've built, purpose-built, you know, solutions in that space. Yeah.
Okay, good. Well, thank you very much. And that's it. I want to thank all the sponsors and vendors that make this whole thing possible, and these two for putting in the time and learning a lot and asking some really good questions. So thank you very much, and everybody for being here. Thank you. And who am I turning this over to now? Turning it over to our friend Werner, who will take you on the rest of the journey, and I think we got you back on time.
I'm just here to hand over to Dr. Sitole that will chair the next session, but Dan, I'm just here wanting to give you this gift as a token of our appreciation for facilitating this. Dan is not only doing this, he's very much involved in the judging of the student cluster competition, so Dan, thank you very much.
What is it?
I don't know.
Oh, okay.
Just a photo. He wants to look at it now.
Oh, thank you so much. This is great. Thank you. Thank you very much. I appreciate it. Oh. Thank you very much. Thank you, guys. Very nice. Really appreciate it.
Yes, good afternoon. So I think after that, we've got our industry partners nice and hot. We can continue and gradually get to concluding the day for today. And with that, we are going to get our last keynote talk for today. And this will be given by Dr. Utz-Uwe Haus. Dr. Utz-Uwe Haus is the head of HPE, HPCAI in EMEA research. He's a mathematician, did computer science, and ran the research lab of HPE. Over to you, Utz.
Thank you very much. So thank you very much for having me again, Dr. Sitole. Thanks for bearing with me to this late evening keynote. And I hope some of the things I've prepared here, which I did before the last session, actually ring back quite a bit with what Dan just said in his intro, but that's not pre-agreed. And you know him, so it can't be. Thanks for being here. I'll run you through what I think are very biased opportunities and challenges, or challenges and opportunities, whichever you want to order it, HPC is facing in the age of AI. And I intentionally put age of AI there and not because of, or with, or in light of. So it's, let's start with challenges. And challenges have many forms. Like if you're an AI person, you would be starting on this graphic and try to infer something maybe, right? You want to learn something. Maybe it's just the queuing because you're an HPC person and you're waiting for 2 weeks for your job to be started. Anything goes, right? So where do we start? We start with a problem that you all know. Who has not seen this graphic? Okay, everybody. I can just skip that. Maybe I shouldn't, because it's not going away. Right? Just because we have AI, just because we have all these great technologies we saw in the last session, performance still depends on transistors, silicon, some sort of technological challenge that with Moore's laws and Dennard scaling leaving us behind is not going to solve the compute solution challenge of the next decade. We can't just scale beyond exascale the same way we did before. And really, this is the picture you have to have in mind whenever you look at reasons why what you're doing is not as fast as you want. So I'll skip a lot because you know the slide, but I like this one better. Who has seen that slide? No one. I'm asking questions to not make you raise your hands. You see, you still have power for the dinner tonight. So this is the same information in this falling curve, which is channel length or structure width, or whatever you want to call it, technology-wise. And basically, at the point where we see the breakdown of Dennard scaling, we see another curve starting, 2010, which is indicating the power per square nanometer compared to this 45 nanometer, which was up to date back then. And we see this tremendous growth of power per square nanometer. And that's how it shows, right? We see structure width is still going down, but we don't have that nice effect of more performance per square millimeter, nanometer, whatever you care about it. Without power increase, now we have the power increase. And this is the one that the cooling talk was about, right? This is the one where you see the heat. And the curve is very steep. There's another aspect which we often forget. And I don't know how many hardware people we have in the room, like hardcore hardware people. Anyone? Again, no one. Oh, one. Great, thank you. So if you look at what I grew up with, Z80 processors, you look at these with a microscope, you see structures that you can understand. I mean, if you do your homework in school. You can understand. There's a breakout, and I really encourage you, if you have a long weekend reading time, to read that Understanding Z80 processor website. It's great. Someone actually went through the trouble of re-understanding what the engineers at Zilog did to put interesting arithmetic units and simple codes like we have down there from hardware into transistors. And you can infer the circuit on that silicon. If you do that for Zen 3, which is the last one I could get a proper public picture of at this level, you take a microscope, you don't see anything like that. And that's not because it's hidden well or silicon has changed or structure width is not there. Well, maybe it's because your optical microscope is not good enough. You take another one. It's because you can no longer see a crisp structure on the chip. Making chips at these new structure widths actually is a huge computational problem to generate unsharp masks, not nice lithography masks that you draw and understand and kind of see your channels and the buffer you need for electrical insulation. You need to have very unsharp masks to compensate for the wavelength effects when you do the lithography, to kind of have a ill-posed reverse problem in the mathematical sense. You want sharp results after an unsharp mask for a well-defined technical problem. And that's where the magic of a TSMC and another manufacturer goes in the end. This is where you look at the structures on the chip and you can't see the actual chip anymore. And we're at a level here where if you look at the wavelengths, you're really suffering. So those are challenges. Those are challenges that we ignore because the next best accelerator is just there. It's going to give you extra power, factor of whatever we had from Intel, 2.5, 6. AMD will say we have AI units in our next CPU. It doesn't matter. This stuff doesn't go away. And with the labs logo on, we have a chance to look at that because for another 2, 3, 4 years, it's all fine, right? In 10 years, we need to see where this takes us. I've not actually seen the computations going into that. I'd love to, but we have only one hardware person, so you're probably not going to tell me the magic. But if anyone is interested, I'd like to learn more about the HPC that probably needs to go into the next generation of that design. And that's where classic HPC goes in. There's another one, and I don't know whether I ask a positive or a negative question here, but Raise your hands just in case, so I see you're still alive. This is the most interesting picture we always forget, which is the energy cost of data movement. It's old, comes from SC10, and it's been rarely updated. Sometimes you see an update, but really the data doesn't change. I'm sure the values are wrong these days. But again, for scale, it doesn't matter. The compute is on the left, right? That's a double precision floating point operation on a 64-bit entity. Whether that's a vector or a simple register, we don't really care. And then you move millimeters across on a chip. And 20 millimeters is a small chip. You look at a NVIDIA super chip, I mean, it's centimeters, right? Data movement costs. It costs an order of magnitude or two in joule just to move words of data on a chip. We're not talking storage. We're talking on chip. Right? So the chip design problem doesn't become easier, and your application software will never see that. It only sees it if, yeah, well, we read from DRAM, or we talked about MRDIMMs earlier, right? These abstractions of there is level 1, 2, 3, 4, 5 in the storage hierarchy. Every time you hear storage hierarchy, you have orders of magnitude of energy cost. There's also latencies, and time is important in HPC, but energy is even more so. So keeping this in mind tells us data movement is a problem. If you were here last year in Kruger, I talked about data movement in general. I'll skip that, but the problem is not going away. And if you realize that fetching an operand costs more than computing on it, that's not only the case when you need to move data onto a GPU. There, people realize, oh, I need to move all that data on an accelerator. I need to move results back, potentially. It's a reality at every level. And this adds up. It's a rather new drawing. I just got it from Tim. It's been shown at SC, but I missed it there. We know this picture as manufacturers. We know it as some customers show it to us during acceptance, but it's rarely published. And I'm happy to have this one here. And take a while with me through this very busy slide. What you're seeing is, for example, an HPL run hidden in here. And you see the public interesting story on cooling efficiency, right? That's the blue stuff. It's mostly fine, right? There's one or two dips, but let's not look into that too much. Let's look at the right-hand side, system power. And we see that moment between 10 hours and whatever, 14 hours in, where we swing from 10 megawatts to 25, maybe a bit more. And the rises on that are super steep. You see power swings, you can't see that here, at minute intervals. And there's actually a data set, if you want to look at that. It's published in Nature Data. If you want to do data analytics on that, you see power swings of megawatts within minutes. If you do that, you better talk to your grid operator. And South Africans knows what it means to have power outages, scheduled ones. You don't want the unscheduled ones. This is what a data center, 30 megawatts is Frontier, that's their max. You could go to Aurora, they're maxed at 60. You talk to some of the previous Bitcoin miners who these days operate the largest data centers. I met someone at SC saying, I have a terawatt, what should I put in there? Typical question to HPE, right? You have all the stuff, what should you put in a 1 terawatt data center? That's 20 El Capitans just for power, right? So you do swings like that, your grid operator is gonna call, or in a blackout situation. This is just the fact that we can start jobs very quickly, and as soon as we move data, energy cost goes up. As soon as we compute and have something to compute, we spike. And we can't level that. That's a challenge. It's a huge challenge. You need more inertia, and inertia in compute and data movement, often we don't like it, but it would be better, right? If your storage system wasn't as quick, you wouldn't ramp up as quickly, right? But then there's still another one, which is on the left here. That's the green one. It's an abnormal termination, an MPI job dying. One rank dies, all the other ranks die. You're not going to curb that. So you have another way of sudden curbs. That's an older one. from a publication. I have that on the notes if anyone is interested. That's a few years older. But again, you have normal termination in the blue line. It kind of winds down. Abnormal termination just goes to essentially 0 and then spikes up when the operating system reclaims your core. And that includes an MPI launch, which has a nice small gap that we know. I mean, there's a small bump. It's orders of magnitude smaller. We need to be aware of where our system is operated, and we might want to adjust to the energy mix. I don't know if Tim got to talk about that this morning. He did a talk on the Exadigit initiative. Can we talk to our operating neighborhood and take extra power or deliver some inertia to the grid? That's a question for the next years. And then there's site stability, and I'm happy to have this picture from Kaust, who now operate 4 big flywheels. You know, this old stuff? They have real big flywheels to operate their system for more than 30 seconds. I can't tell you the true time, but that's the time where generators can kick in, right? That's inertia, physical, moving mass, not semiconductors. But how do we do that at 600 megawatts, right? That's the Bitcoin miner facility that needs new AI in there. And they're looking at AI investments instead. I don't know, that's a business model, but for them it is. It's going to be hard. So how does AI get into this? And there's a typo, but it's due to flights. So we get larger systems. You would say exascale is big. Yes, exascale is big. But traditionally, if you look at the top 500, there's a dwindling of power after 50 or 80 place. And then that size will push up. People call it AI factories, maybe. That's because factories are great, right? We need more industrialization in the deindustrialized world. So AI factories is a great name. What it means is an entirely different discussion, but we buy a lot of accelerators, big systems. We get new user communities, in particular, more mobile user communities. Now, someone doing scientific compute always was ready to take any system they could get access to, and they were happy to get a few CPU hours here, a few GPU hours there, and take their code. But they were expecting a transformation of their code to be required to new systems. The AI community is not like that. I say it runs on any cloud, so it should run on your system. Here I am, and if I don't like it, I'll go away. That's the new mobility. And there's new usage patterns. I'm not saying Python, but I could. I'm looking one step further, which is more preemptible workflows. We're used to monolithic jobs in HPC, which, if you teach people well, have proper checkpointing and will resume if you kill them or if they get killed due to timeout. But people shy away from doing that too often. On the AI side, for training, it really doesn't matter. You know the iteration number, you start again with very little checkpointing information required and typically available in the frameworks. So that's actually a good thing. On the other hand, we need to run services. And most centers don't want to run services on login nodes, on front-end nodes, on permanent reservations, because it's against our view of you pick a job, you pick a part of the system, you utilize it well, and then you go away with your results, right? Services for inference, for example, are required, or for data absorption and continuous training. We also get less optimized codes from the user side. We see one-off workflows, huge pieces of code that do one thing and that will never be optimized because the next one will be different. We see more toolkits. Everybody needs PyTorch. And we see different data access patterns. Big data style is what I call it, so mix of sources, not well-curated data formats, and suddenly we see requirements on secure data. But if you take a step back, this is not new. Right? The same happened with different topics, different items, different participants every other decade. Right? When the big data wave was bringing Hadoop onto HPC systems, people were complaining. Nowadays, it's just one more tool. When the PVM users wouldn't go away because MPI was the new rage, There were some issues on the access patterns. How do you run a PVM server? But that has changed. In the end, all of these, HDF5 wasn't there forever, right? I mean, you have things that change. You bring new communities on. Most centers are happy to have new users because more users means more investment, more sustainable operational models. So you need to deal with that. And so AI is just one more challenge of a decade. Then it will turn into standard fare and we'll see something additional, not in lieu of. So let's do some opportunities because this was maybe boring enough. I tried to group this into 4 columns based on what I just said, essentially. Not all directly AI, but all of these have a reason in the new usage patterns if you go deep down. We see more heterogeneity. Right? 15 years ago, no one used GPUs. Now everybody needs them. There's other accelerators coming up. Some of them will go away, some of them will stay. We'll just have to watch what proves useful. We see in-memory computing being discussed again. It was like almost 10 years ago, and it's coming back. We see quantum as a topic, quantum integration in particular, not a big device that some physicists like to play with. I mean, that exists, and that's perfectly fine, because the transistor was like that in 1927. But that's not compute. It was a transistor in a lab, right? Like these big ones that look like a sugar cube, right? Or actually a cube. So integration is a topic, and I'll talk a bit more about that if time permits. Then we see new old abstractions, as I would like to call it. So all the open MP, ACC, and so on paradigms don't go away. At the bottom, they stay, and some of them actually adapt to these new environments quite well. PGAS, Partition Global Address Space, is coming back. I'll tell you why I think that's the case in a moment. Tasking is coming back. And it's coming back every few years, right? And then people try it and feel, ooh, it's a lot of work to rewrite my code. But it's there, and MPI is not dead by any means. We also get new abstractions, and I didn't want to duplicate the title, so I called it More Portable Software Stacks and New Abstractions. Containers. When we did the first container experiments, it was painful. 2016, 17 maybe? Shifter, because Docker was not useful on HPC systems. That has been resolved. Containers are there to stay. We see more libraries. That's a good thing instead of intrinsics. More open ways to port your code and transport your code. And we have these mobile user communities, so that's very important. We also see a compiler backend unification. LLVM is everywhere. And we see more middlewares and couplers, as well as cloud tools and even federation. I'll go into details for some of these on the next slides, but I just want to run through them once. And we have a whole column of opportunities in twins. And I'll take the term twin to be much wider than what you expect, I hope. We saw data center twins this morning from Tim, because that's something we really care about in the group. We see twins of compute systems, also part of that, understanding what's really happening. If you look at the power spiking diagram that we have from Frontier, why didn't we have that 10 years ago? Because people didn't look at it for a reason. They said, oh, it's painful, we have to call for the HPL run, we have to announce that we're going to run it tomorrow. And then that was it, right? Now people care. They try to understand what the cooling loop is doing and whether the efficiency is still the same, whether the data center overheats. One part of twins for me is using models instead of first principles, physics-based codes. And some people call that AI. So take that step with me if you want, or ridicule me afterwards. If you put a trained neural network instead of a nice convection kernel into your code, you're taking a twin. A twin is a model that represents certain aspects of your system well enough to be useful for predictions, and whether that's AI-based or any other base, I don't care. But many uses of AI that we see these days are in this class, replacing pieces where a first order Taylor approximation is also just a model, right? So you have AI in the depths of this, and AI systems present twins of other systems to us. So I hope no one is really offended for AI being in the bottom right corner of this and not even called that. But that's how I see it. It's another tool. It's another piece in the puzzle. We're going to have it. But it's not that strange animal in the room. I think I lost a slide here. Let's see how that goes. Maybe it's coming later. So let's do quantum first. That was in the left column. So quantum today is experimental quantum. We have some systems. HP is working with IQM quite closely. You saw that at ISC and SC if you were there. We can show you a demo. I hope I have a video. Otherwise, we can link one up. To integrate it with an HPC system so you can farm out small pieces of your job. What I'm not claiming is that we have an advantage. I'm also not claiming that we have problems that need HPC and quantum at the same time necessarily, but technologically we're ready. We can farm out to quantum. Depending on how big your quantum system is, it may or may not be interesting. Some HPC simulations may become faster if you have enough qubits. We'll also realize how much simulation of quantum system will play a role, both for system design, but also for debugging. You can't debug or single-step a quantum system, ever. It's a physical thing, you can't do that. Otherwise it wouldn't be quantum. So we'll need a lot of special purpose simulation tools to work with quantum systems until they become so robust that maybe we have a small quantum system to single-step parts of the big one. But that's far, far out. So if you have a big HPC system, it might be busy just running quantum simulations of parts of what you're running on the real system. But there's also tuning aspects to the physical properties of these devices, because they're complicated devices that may need an HPC system just to steer it. At some point, we believe we'll see quantum accelerators coming in, just like any other accelerator. Maybe not in the physical form factor of a CXL module, but that's a technicality. And the rest is 10 years out, or more. In there, well, that's more a marketing slide. The take-home message is really, at this point, HP is involved in that, but at the level of helping to get a level field of understanding how quantum would be used in the data center, not selling solutions for, oh, this can be done with quantum. And I'll show you one or two examples, and then you'll see more why I think that's the better approach, because we don't have anything that can be solved with quantum today in reality, right? You see a lot of glossy things. Always question what the relevance is of any experiment you see. This is one, right? If you have anyone telling you portfolio optimization is a great thing for quantum, ask them whether they invest their own money with portfolio optimization with quantum. And if they do, ask them again in a few years. It's an interesting problem. So I could talk for an hour just on this problem because I like it as a mathematician. But fundamentally, it's very easy. You have to select a mix of assets, let's say some stocks from a major index, so that either your risk is maximized or your risk is minimized. That's an investment strategy. But at the same time, you want to reduce the trading frequency because each trade costs money and churn. So maybe you can take 30 of the S&P 500. So that's a limit that requires you to select a discrete subset of these items. You look at the cross correlation, solve a binary optimization, binary quadratic optimization problem for max or min variation correlation. If you solve that continuously, it's super easy. Newton first order is just enough. You get the percentage of assets. But if someone tells you, now you can only take 5, the solution will always be dense. You can only take 5. That's where the hardness comes in. That's NP complete to decide, or NP hard to solve, whatever you want to look at. And it decomposes reasonably nicely because you can run some of these sampling of proper variations with quantum if you have a sufficiently large system. Look at the US stock market, it's like 200,000 stocks. That's a lot of qubits, a lot of ideal qubits, not physical qubits as we have them today. But we built a nice demo that ran at SC to show you how an MPI application can be used to combine the parts. If you had multiple quantum machines, they could all feed to some ranks. You combine the results, you farm out another round. So in the sense of an accelerator, if you believe the sampling done on this quantum level is much better than some Monte Carlo method you run classically, it's ready, right? So that's quite nice. We had a competition. People could bet against that machine, and someone won a PlayStation. On the floor, there's a nice picture. You can still beat this any other way. There's more. I'll skip in the interest of time. People put quantum layers into neural networks just because you can. You can model certain behaviors that you can't with a step function or a summation or all the other layers you come up with, convolutions. There's a quantum layer. So why not, right? Technically, that's quite easy, as long as your layer is matching in width the number of qubits you have, or you can disaggregate it and buy 100 quantum machines. So technically solved, practically still to be proven. And then there's the famous one that everybody likes to mention, and I think there's even a talk at our booth. I saw someone copied a tech talk of Agnello from our team on doing max cut, so maximum cuts in a network, very classic graph problem, one of the CARP problems of the 70s on complexity. And that can be solved by a divide and conquer iterative procedure to some level of non-guaranteed optimality. Then you have a Guman-Williams bound, so you can kind of check how bad you are with your heuristic. And this heuristic can be implemented cutting down to whatever your qubit number is. Now, if you have only 5 qubits, that's awfully small subgraph. In a large complex graph, 5 is just wrong. But if your graph is only 100 nodes and you have 100 qubits, maybe you get along quite well. And again, this is a tech demo saying we can distribute the pieces to multiple quantum devices, or only one, and queue it up and gather the results, farm out again, like you would do with an accelerator. And it uses all the stuff we know: MPI communicators, MPMD launches, dynamic process management. So the tools we have on HPC are very much sufficient to get this done. There might be changes we want to do in a proper quantum software stack to be more naturally offering a decomposer paradigm rather than MPI ranks. But that's a layer above. And this was actually run on Lumi, this European pre-exascale system, with all open source software, and then a backend from Classique, which is not open, to transform to different target machines, because we wanted to be portable to different quantum modalities. We only tested it with IQM, because they're our current preferred partner. But if that was not the case, Classique would be the compiler backend, so to speak, the one that can talk to all different modalities. But that could be replaced by something else if you want to. There's another one. There's one on resource scarcity. And you don't have many quantum machines per lab, so you need a way of assigning resources to jobs. And again, we argue that at least for some use cases, that's quite easy. I mean, the trivial one is here. You just put it as an extra resource into your Slurm allocation. And that's fine. However, you block the device for the length of your job, right? That's not great if you only do a bit at the beginning or a bit at the end. So instead, what you really want to have is a different class. Again, you would say, okay, I have a device class in my Slurm queue, so I need to run a heterogeneous job where some components are quantum, some are not. And again, that can be done, and maybe with a coordinator rank somewhere. So we demonstrated that to be quite there. Then the next interesting step is really to say, how can we reuse the quantum device when one job doesn't need it anymore? For a moment, this still works by realizing that if a node leaves a heterogeneous Slurm job, it's available to be scheduled on by other jobs. The only question is if your first job wants it back, then Slurm doesn't have that. So now we're in tasking land, where we need an extension to make this resource dynamically available to running jobs. And that's not very different from other things that Slurm doesn't do well, namely all the things Kubernetes people love, right? To say, I have an extra need for a few nodes now. It's the same workload, it's the same workflow. Now I need some extra nodes and now I need to give them back. Maybe I need them again later. This elasticity in workloads is coming in through the back door for Quantum because we have fewer devices, not because we have elastic workloads only. And I think that's a nice way to see from both sides elasticity on HPC and tasking is coming back. All right, so that's the one I didn't go into detail on the column number 2. Classic PGAS is not going away, but it's niche, right? If you've programmed UPC, then you know what I mean. Most of your friends will not understand what you're writing. But I believe PGAS is coming back in other versions. If you hear fabric attached memory, fabric addressable memory, in some sense, that's another way of looking at PGAS. You share across nodes, possibly across applications, the knowledge of an object on storage at an address. Right? So now the storage is responsible, or the memory class storage is responsible for keeping that address valid, but every node can access it. So that's PGAS. The same for object stores. You rely on the object stores to do the data locality for you, and you call on items by name. Maybe they're striped, maybe they're not. That's part of the implementation, but everybody can access everybody's data pieces by a non-path accessor. And when I say object stores here, I don't really think of S3, because that's too coarse a resolution. I'm more thinking about Deos or similar frameworks, where you can have the layout under control. And even locally, if you look at unified memory, that's the big story of all the chiplet-based, multi-type accelerated designs that we see coming for the node level. That's PGAS, right? GPUs don't share memory in reality. Someone is doing that for you, hopefully in good hardware. And if not, then you'll see the same issues we saw on KNL and friends. Local is local, and the global view is maybe not as smooth as it could be. Tasking is at the bottom. Let's go bottom up. OpenMP, OpenACC offloads, quite nice. C++ abstractions that don't even tell you where they want to offload to. And also coroutines in Go or Python abstractions. They all do tasking at a local level. But we see more. We see it in offloading. If you do in-storage compute, I think the VAST talk just had that somewhere hidden on the right corner. Essentially, it's tasking, because you need to define a task with input, output, pattern, guarantees, data locality information, and then you can ship it to a specific device that might have a very different CPU. Maybe it's a RISC-V CPU in the end, right? It's not homogeneous. You offload a task, you expect a result. In network, in memory, same story. So you're required to break down your program into proper tasks. Otherwise, you're going to die the ship this kernel to that, expect a return result. If you don't have data dependence as you have in tasking, this is not going to be an advantage. And we see it even more globally. If you talk about federated HPC systems, that's one of the topics. And that brings us to the conference theme, right? We're looking at cyber infrastructures outside of a big but secluded data center. And I have to raise a flag for MPI, not because I love it so much, but because it's easy to miss some of the slow but existing progress on that. It's still the classic HPC model for many codes, and behind the scenes, it's being used as if I need a working parallelization tool on an arbitrary system, I pick MPI, even for sysadmin duties, right? Or to shake out a system. It's just there. We've actually had discussions with LRZ, Martin Schulz, on putting some of the system management on top of MPI, assuming some sort of MPI will always run. Which particular network it's using, well, that's a thing for performance. But at sysadmin time, well, a gigabit Ethernet is just fine to run MPI on, and you can very nicely shake out nodes and configure them. It's not a product, not even a research project properly, but it's just there as a topic. And then there's malleable jobs. And that goes back again into the tasking, into the elasticity. And I hope really we get a standard for that in the next year or two. And we see our quantum integration efforts relying on it because it's functional. The new abstractions, containers, Singularity or Aptainer, your choice of license model, and Podman HPC have essentially won. We see vendor-provided application stacks. So if you go to AMD and say, can you tell me how to run application X optimally on my AMD system, they will not give you parameters for the compiler line anymore. They'll give you a container where they say, it's in here. That has advantages and disadvantages. It's easy to get started, but you don't know what they did, right? And it's always depends on the vendor whether they also give you the recipe of what is in the container in case you need to rebuild it. Some vendors are better than others with that. And then there are some issues like assumptions on OpenMPI versus MPICH or MVAPICH that is baked into the container and rather hard to pry out again. Also versions of Python madness, all of that is in there. If you need what you get, fine. If you need to change it, we need more openness on the container environment. But it's there. People will bring containers to whatever system you have. And the positive side is with containers, you can actually build a secure HPC environment by curating containers, by signing them, encrypting them. You give users a method to get data and keys onto a system in a secure fashion without storing them in their home directory, accessible under Unix permissions. So that's a strong point for containers too. There's libraries beyond BLAS. That's a long evening discussions, which ones you think are important, so I left everything off. Compiler is a different thing. It's great to have LLVM everywhere. At the same time, I'm very afraid for the general stability ecosystem. If you have a major problem in the LLVM supply chain, all vendors that depend on it are doomed. And that's a concern for the industry, I would say. On the other hand, if you have a simple backend for LLVM for your fantastic accelerator that is not even on the market yet, well, you're up and running. Right? We just ran on a RISC-V bitstream that is supposed to be the basis for the European accelerator. We just ran a Linux kernel on there. We ran the IFS dwarfs, even though it's not even a proper platform yet. Right? LLVM makes that possible. We see more and more middlewares and couplers, and we saw them in last year's conference, so again, I'm not going to jump in here. And if your favorite name is missing, tell me about it, and tell me why it's good and what makes it different from others, so I learn about it. And then we have the whole cloud tools and federation story. Kubernetes is there, or one of the variants of Kubernetes as a concept. We see much more interesting identity and access management requirements and solutions, and even more containers. I'm running short on time here. Happy? 2 minutes? 3 minutes? Okay. So if anybody wants to sell you federation, show them the Webster quote. And you can forget about the rest of my slide. But it's the act of creating or becoming a union of organizations. It's not everybody is the same. It's not copying what one does to the other. You need to find agreement and stay separate. That's a political challenge. EuroHPC wants to unify all their systems in terms of federation. And they don't realize that everyone is under national legislation, which is different. And there's a huge discussion point to be raised beyond just the technical feasibility of having user accounts federated. Network connectivity, identity management, code mobility, and data mobility are the core topics here. And with that, I'm going to show you, can someone click on the video on the left, just so we have a bit of, on the left there should, for you with a mouse, there should be a way to click on that video on the left to run it, just so we, on the left, click on, yeah, so there we go. Well, it's, yeah. So this is my take home, nice picture. HPC is still good for something. We see the climate simulation I promised you last year. in action at 5 km scale at the bottom and at 150 km, which is the de facto public policy-making model scale our politicians have. You see the difference. Temperature and wind is being shown. If it's dark, then there's no wind. If it's bright, there's wind, and the colors are the temperature. For a 30-year out simulation of European climate, we did that for the whole world at 5 km in May, end of Destination Earth Phase 1. I think this is fantastic imagery. You can understand how much more you can see about local phenomena, about details, winds behind mountains. Mountains actually appear, right? And if you want to make predictions on wind farm efficiency, this is the level you need, not what we had before. And on the right, you see twins for data centers, but you had that this morning, so I don't need to go into that. So, summary, AI brings new communities to HPC. The computer science problems have not really changed, and HPC is here to stay. Thank you. Yep.
Thank you very much, Dr. Utz,
Thank you.
for this interesting talk.
Thank you.
I think what is pleasing is right at the end to just guarantee to us that HPC is still here to stay.
Yeah.
Maybe let me just check if there might be some one or two questions quickly to Utz. Any burning questions? I don't see any. I think what will be interesting is the simulation that we just showed of the
climate twin.
Yeah, the climate twin. In terms of the resources, are you able to tell roughly on
this
how
is
much
fantastic.
of
So Lumi,
constitute?
Tim, help me out. How many GPUs do we have on Lumi? Many. You can look it up. Thousands. It's 2.5 months of compute time in total. This is still not the full data deluge we're expecting in this phase. Like end of this year, we're expecting 1 petabyte a day of traffic out of 3 simulations for 30 days of simulation time. So you can't really store that. You have to boil down and quickly analyze and then only store what you need to resume if you need to repeat year 26 or 27. At the same time, a lot of data is stored. There's a public platform that I don't think I had the link on. It's called platformdestiny.eu, where you can see some of the data for your favorite location. That's really nice to play with and shows how much we can do citizen science with the outcomes. But at the HPC level, this data can't even leave Lumi because it's too much. They fill up the storage with all of it. 35 petabytes is what they have. So it's a huge classic HPC production, then a data plane, a database, field database of ECMWF, and the analysis steps running in parallel live as the data comes in, because you may not be able to see the same data again. So in that sense, very complicated and nice workflow.
Okay.
Including AI steps, of course, right? So not even talking about that anymore.
Yeah, that was going to be my question, whether there was any AI.
So
Was
in
it,
this
on the
imagery not,
pre-processing?
but in the downstream processing, there are some steps which are AI-based, and they just see the frames coming in, grip frames coming in, and look at what they want. Like, for example, one measurement that was boiled down was wind speed at a particular location, in a particular height that had to be interpolated. And they had a predictive model instead of doing whatever linear interpolation of that to get that data right for a platform up in the North Sea.
Okay.
Yep.
Yeah. Thank you, Dr. Utz. Let's just thank our speaker once again. Okay. Oh, okay. Okay. Thank you.
Thank you. Okay. The one you gave me last year.
Oh, it's a Mickey side.